Okay, so take three. I'm trying to do this, my camera's not cooperating, but anyway. I've put this together already as far as the experiment. Um, I'm going to tell you what was supposed to happen and tell you a couple reasons why mine's not working, I think. First off, this is an experiment meant to kind of model the galvanic cell. And in that experiment, as we watched earlier in the week, you had um, a zinc component, and then in the other solution there was copper component. With that, uh, there was a salt bridge between the two, and that salt bridge served the purpose to help ions from one solution come into contact with it, or move over the salt bridge into the other solution to start a circuit. So zinc, when it would lose electrons, would oxidize, those would create a charge, and then copper on the other solution, when those would release electrons, it would start to have a charge, but when we close the circuit, like in that experiment where we would connect the two solutions up to the machine that would check the voltage, the zinc ions would flow up through the machine and come back around, dump into the copper, and so the copper would bond with the zinc ions, so it would be reduced, and the zinc would oxidize, and so it would leave a charge. So this experiment was trying to replicate that. I did have zinc screws, I had copper clips, I had wires connected to each end of the lemon, but these are a couple of reasons why this is not working out how I think it was supposed to. One, I didn't know the composition that the wire needed to be for connecting the zinc to the copper clips, so I just bought wire at Lowe's, and turns out I bought copper wire. So my thinking on that is why that might be an issue is because take the video I was referencing earlier. When you had that experiment, we didn't have zinc directly contacting the copper. There was the bridge between the two solutions. So I almost feel like there had to be a different component, like a salt bridge, that would have actually supported this reaction to take place. The next thought is some of the copper, which I've tried to tighten that up a little bit, but some of the copper wire is loose. And I don't know how tight to tighten it for this reaction to be successful, and so that might have been an issue. And then lastly, third issue, I guess, the steel wool I got, I grabbed Brillo pads, I guess not really thinking, and so there's soap mixed in with the Brillo pads, so that might be preventing this reaction from taking place as well. And again, I'll just show you kind of what it's not going to work, but anyway, you can see I gave it a shot here. But anyway, the reason that going back to the video experiment, the copper reduces, doesn't oxidize, it reduces, is because it's going to collect or grab onto those zinc ions that are coming back around in the circuit. So that'll kind of reduce it down with the zinc. Because it is passing charge through, passing ions through, it's going to have a charge. And so in my head, when zinc would give up the electrons, so we're losing negative energy, which means we're going to have a positive charge on the zinc. And then copper, because it's taking on electrons, is going to have a negative. But I'm pretty sure in the video, the gentleman said it was the other way around. So maybe more explanation needed there for me on this one. But all in all, if I had to do it again, get a different wire to use for clipping between the zinc and the copper clips. Don't use Brillo pads that have soap in them, and make sure the wires are tightened up really well. Yeah, so other than that, that's really all I have on this one. The other videos took more time because I was actually putting this together in the video, but as you can see, you've done it. Let me try to lift this up so you can see the contraption here, I guess. But all in all, this is a failed experiment in the books for me this week, but we'll give it a shot again next time. So thanks for listening, and have a good week.